ठीक है जी। तो स्टार रिंग और बस हमने डिस्कस किया था and ethernet we have discussed. I would like to tell you regarding an ethernet because most of the time students are not clear regarding what the ethernet is. Actually जो भी हमारे पास स्टार बस और रिंग टोपोलॉजीज हमने डिस्कस की हैं, for each we do have certain sort of standard, right? So ethernet standard is used for our bus topology or bus networks. ठीक है जी। हमारी जो बस टोपोलॉजी है that is based upon an ethernet और उसके अंदर how your data is going to be how your devices are going to access your data, access your medium, that all is depending upon the ethernet based technology. ठीक है। और उसके बाद हमारे पास FDDI है and then we do have the ATM. These are the technologies जो आपके पास रिंग और स्टार के ऊपर बेस करती हैं. But right now you have to understand that Ethernet is purely based upon your bus topology, bus networks, right? So yesterday we have discussed also regarding carrier sends multiple access. ठीक है। अब देखें CSMA, that is called as CSMA, right? And then we have the extended version of CSMA that is called as carrier sends multiple access collision detection and collision avoidance. I mean CSMA CD, CSMA CA. CSMA stands for carrier sends multiple access / CD stands for collision detection and CA stands for collision avoidance, right? Second thing that we have discussed yesterday, Ethernet standard according to IEEE Ethernet can be called as IEEE 802.3. ठीक है। ये आपके पास एक नंबर है, that is a standard, that is the name of the standard that is being used for the Ethernet based network, right? Or Ethernet LANs, we may say that. For Ethernet LANs, the standard that is being used, that has been given by IEEE, that is called as 802.3. Now the question is, why 802, right? Why 802? I mean, most of the time this is a very general question. People used to ask that why not it is 202, why it's only 802. Now 802 means that it has been given in 1980s, right? And in the month of Feb. ठीक है जी। ये स्टैंडर्ड जो आपके पास है that has been given around in 1980s and 2 means that is in the I mean to say that in the month of Feb, that is Jan and Feb. So that is why it is being called as your 802, right? So this is in standard. This is just for a general information. I mean, if somebody asks you that, why 802.3, why 802.11 or something like that, so you must be knowing that, right? कि actually इसकी basics या इसके backend के ऊपर logic क्या है कि हम why we are going to call it at 802. The reason is it has been given in 1980s and in the month of Feb or related to that, right? So this is what related to the Ethernet. And then I would like to tell you the basic idea regarding carrier sends multiple access. Now this is how I mean, in a bus topology we know that we have a shared medium. I think yesterday in the last class I've told you that what does the bus topology works upon. I mean, how does the bus topology works upon? It actually works upon a shared medium. आपके पास एक shared connectivity होती है, ये shared media होता है, and all the computers are going to access that particular shared medium. Now what is the problem with that? The problem is if multiple computers are going to send the data at the same time, it will collide and it will jam your network, or it will reduce the bandwidth of your network, because when the collision occurs you cannot send and receive the data during that particular collision. So that is why now you have to understand the concept of carrier sense, and then you have to understand the concept of multiple access. Now see, carrier sense means your data has to sense the carrier or sense the medium, right? I mean, आपके डेटा को सेंड होने से पहले आपके कंप्यूटर ने आपके जो मीडियम है उसको सेंस करना है, whether that particular medium is free to send the data or not, right? This is what the carrier sense means. And multiple access means that multiple computers are going to access the same shared medium, right? So you have to keep this thing inside your mind, that what does the carrier sense multiple access means, right? I mean, the word CS means carrier sense, and carrier sense in actually means is how your computers, I mean before sending the data over the LAN or over that particular shared medium, your computer has to sense that particular medium, whether that medium is free or not. If the medium is free, it will send and receive the data. If the medium is not free, it has to wait for a particular amount of time. And multiple access means that multiple devices, I mean with that particular single medium there are 10, 15 or 20 devices are connected and they are going to access that particular media. That is why it is called as your CSMA or carrier sense multiple access. ठीक है जी. अब इसको मैं थोड़ा सा पढ़ देता हूँ आपके लिए स्लाइड को. A coordination scheme that defines how to make turns using a shared cable. I have explained you. A computer listen to the cable, carrier sense. If the cable is idle, then start transmitting. If the cable is in use, then it waits. ठीक है जी. अगर वो फ्री है तो डेफिनेटली वो स्टार्ट ट्रांसमिटिंग कर देगा, एंड इफ इट इज इन यूज then it has to wait. If simultaneous transmission occurs, the frames interfere with each other called a collision. I mean, I've told you that if the simultaneous transmission is going to be occurred, तो आपके पास क्या होगा? Ultimately, you might have a certain sort of issue, right? Okay. ठीक है. देन आ जाए कोलिजन डिटेक्शन के ऊपर. अब मैंने आपको बता दिया व्हाट इज सिस्मा, आई मीन कैरियर सेंस मल्टीपल एक्सेस. होपफुली दैट इज क्लियर. अब हम आ जाते हैं कोलिजन डिटेक्शन, जो इसका सेकंड पार्ट है. अगर सिस्मा /CD लिखा होगा, दिस मींस दैट कोलिजन डिटेक्शन. अब ये चीज आपने जरूर मेंशन, आई वुड लाइक टू एक्सप्लेन हियर दैट सिस्मा CD इज बीइंग यूज्ड फॉर द ईथरनेट नेटवर्क्स or Ethernet LANs, right? In which you have the wired network. That is not a wireless network. For wired network, you might be using SISMA CD, I mean collision detection. Now, what it is? I would like to tell you, signals from two computers will interfere with each other. I mean, if they are going to be sent over the same medium, there must be a collision, right? Overlapping frame is called a collision. No harm to hardware. Data from both frame is grabbled. I mean, when the collision occurs, there must not be any problem with the hardware over which your data is traveling. ठीक है, आपके हार्डवेयर को या आपके कंप्यूटर को कोई नुकसान नहीं होगा, but actually the data that is being traveling over the network, that is being garbled, right? And it might be creating problem for the data. So what is Ethernet CD? Ethernet interface includes hardware to detect transmission, right? Monitor outgoing signals, garble signals in interpreted as a collision. After collision is detected, computer stop transmitting. So Ethernet use SISMA CD to coordinate transmission. अब देखें होता क्या है. होता ये है कि as soon as, let's suppose, every computer is going to sense that particular medium. ठीक है, उसने सेंस किया, उसने चेक किया, there must not be any other data over the medium, then it will start transmitting the data, right? And that would be a normal. Once that data is being received at the other ends, that's fine. But in case if there is collision, collision कब होगा? When computer A and computer B mistakenly send the data at the same time. ठीक है, तो मीडियम आपका शेयर्ड है. जैसे ही दोनों डेटा आपके मीडियम पे पहुंचेंगे, and when they reaches, I mean when they collide with each other, ultimately a collision happens. ठीक है, आपके पास स्ट्राइक होगा, collision होगा, and definitely your data is going to be lost, right? And the network is going to be down because due to that particular collision, आपके पास आपका जो network है, it is going down, right? Now, अब आ जाए रिकवरी फ्रॉम कोलिजन. अब कोलिजन तो हो गया, ठीक है जी. अब सिस्मा सीडी, हाउ डज इट वर्क? आई मीन अगर आपके पास कोलिजन अगर हो जाता है, देन व्हाट इज गोइंग टू बी हैपन? कंप्यूटर्स दैट डिटेक्ट अ कोलिजन सेंड स्पेशल सिग्नल टू फोर्स ऑल अदर इंटरफेस टू डिटेक्ट कोलिजन. Computers then wait for others to be idle before transmitting. If both computers wait same length of time, frames will collide again. Standard specific maximum delay, and both computers choose random delay less than maximum. अब होता क्या है कि when collision occurs, every computer is going to halt itself for a particular amount of time, जिसको हम कहते हैं बैक ऑफ टाइम. ठीक है जी, बैक ऑफ टाइम आपके पास मिली सेकेंड्स में होता है. दैट इज फ्रॉम, लेट्स सपोज, फ्रॉम 0 मिली सेकेंड टू t मिली सेकेंड. t इज एनी वेरिएबल, ठीक है, हम उसको 5, 6 या 10 नहीं कह रहे. आई एम नॉट गोइंग टू हार्ड कोड इट, ठीक है. मैं इसको ये नहीं कह रहा कि जी 0 मिली सेकेंड से 10 मिली सेकेंड्स. मे बी इट वेरीज फ्रॉम कंप्यूटर टू कंप्यूटर, ठीक है। तो मैं क्या कहता हूँ, जैसे हम कहते हैं ना लिमिट इज स्टार्टिंग फ्रॉम n इक्वल टू 0 टू x। अब 0 टू x का क्या मतलब है, एनी वैल्यू दैट इज बिटवीन 0 टू a particular variable, right? और x कैन बी 15, 1500 और 15,000। x की वैल्यू कुछ भी हो सकती है, ठीक है। इन द सेम वे वी आर गोइंग टू डिफाइन दैट पर्टिकुलर अमाउंट ऑफ टाइम फ्रॉम 0 टू t। अब होगा क्या, जैसे ही कोलिजन अकर होगा ओवर द मीडियम, आपके पास जो डिवाइस होगी दैट इज गोइंग टू ईडल इटसेल्फ और इट्स गोइंग टू बैक ऑफ इटसेल्फ फॉर अ पर्टिकुलर अमाउंट ऑफ टाइम। अब बैक ऑफ का क्या मतलब है कि जी लेट सपोज अगर कोलिजन अकर हुआ, कंप्यूटर ए ने अपने आप को ईडल कर लिया फॉर 0 टू t मिली सेकेंड्स, ठीक है। उतने टाइम तक अब वो दोबारा डेटा सेंड करने की पोजीशन में नहीं होगा ओवर अ नेटवर्क। व्हेन that particular collision has to be normalized, आपके पास डेटा, आपका जो नेटवर्क है वो फाइन हो, I mean it is going to be normalized, there must not be an issue after collision. After that particular amount of time, again when that particular back of time is finished, let's suppose it is a 10 milliseconds or a 15 milliseconds for computer A, it will again send the data, right? And then there must not be an issue, right? So when collision occurs फॉर अ पर्टिकुलर अमाउंट ऑफ टाइम, आपके पास वो दोनों कंप्यूटर्स जो सेंडिंग और रिसीविंग एंड के ऊपर हैं, जिनका डेटा कोलाइड हुआ है, वो अपने आपके ईडल टाइम के अंदर चले जाएंगे एंड नो डेटा इज गोइंग टू बी सेंड एंड रिसीव्ड ओवर दैट पर्टिकुलर मीडियम वंस द कोलिजन अकर्स, राइट? सो दिस इज हाउ योर रिकवरी फ्रॉम कोलिजन इज गोइंग टू बी अकर्ड। नाउ सी, अब देखें, इट कुड बी द पॉसिबिलिटी the back of time for both the computers is the same. I mean let's suppose कंप्यूटर A और कंप्यूटर B ने डेटा सेंड किया, दोनों आपस में कोलाइड हुए, कोलाइड होने के बाद दोनों ने अपना जो बैक ऑफ टाइम है वो कितना रख लिया, 10 मिली सेकेंड्स, राइट? नाउ व्हेन दे बोथ select their back of time for 10 milliseconds, when they will come again, I mean when they again wake up from that particular time millisecond, ठीक है, दोनों का 10 मिलीसेकंड था। अब जैसे ही दोनों रिकवर हुए उस बैक ऑफ टाइम से, they again send the data at the same time and again collision is going to be occurred. When again the collision is going to be occurred, आपका जो back of time है that is going to be doubled. Are you getting me? If it is 10 millisecond, it becomes 20, right? So this is a random time that is going to be assigned by a different type of computer. I mean it varies from machine to machine, that how that particular machine is going to assign that particular back of time to a particular computer, right? So this is the basic ideology regarding the collision detection mechanism, ठीक है जी। आपके पास वो बैक ऑफ टाइम होता है, उस बैक ऑफ टाइम के लिए अगर कोलिजन अगर होता है तो आपकी डिवाइसेस जो हैं they are going into a silent mode, or you may call it as an ideal mode, and during that particular ideal mode you cannot send the data. Your machine that is in idle state must not be able to send the data over that particular medium until and unless the things are going to be normal down, right? So this is how your collision detection mechanism is going to be executed. I mean this is what the CSMA CD, and this is Ethernet, I mean this is being used for the Ethernet 802.3 standards, IEEE 802.3 standards, right? So this is how your Ethernet collision detection occurs and how it is going to be recovered from that particular collision, right? After waiting, computers use carrier sense to avoid subsequent collisions. Computers with shorter delay will go first, other computers may transmit later. I mean अब देखें, जैसे कोलिजन अकर हुआ आपकी डिवाइसेस ईडल या साइलेंट मोड में चली जाएंगी, तो जिनका I mean delay time small होगा, they will wake up again and send and receive the data, and those who have the larger amount of delay they will send it later. So by using collision detection mechanism you are going to avoid collision over the IEEE 802.3 networks or IEEE 802.3 Ethernet networks, right? So this is how your CSMA CD works. So exponential backoff, the same word term that I have used, exponential backoff. Even with random delays, collision may occur, especially likely with busy segments. Computers double delay with each subsequent collisions, reduce likelihood of sequence collision. ये मैं बता चुका हूँ आपको, ठीक है? Exponential backoff or backoff, the same thing. That is the backoff time that I have just explained you regarding CSMA CD, right? So this is what the CSMA CD, that is called as कैरियर सेंस मल्टीपल एक्सेस, कोलिजन डिटेक्शन। बट मेक श्योर ये चीज आप याद रखें, ईथरनेट IEEE 802.3 is a standard that is being used for Ethernet, और Ethernet आपके पास बस टोपोलॉजी पे वर्क करती है, बस नेटवर्क्स के साथ वर्क करती है, ठीक है स्टैंडर्ड। और Ethernet स्टैंडर्ड या IEEE 802.3 के अंदर जो कैरियर सेंस मल्टीपल एक्सेस टेक्नोलॉजी यूज होती है, दैट इज कॉल्ड एज योर सिस्मा CD। मेक श्योर सिस्मा CD इज स्पेसिफिकली यूज फॉर Ethernet 802.3 स्टैंडर्ड, मेक श्योर, ठीक है। ये आपके पास वायर्ड लैन के लिए यूज होती है, वायर्ड लैन, राइट। Ethernet इज अ वायर्ड लैन, ठीक है, whether it is a bus or star or whatsoever it could be, लेकिन for bus topology you have 802.3 and the mechanism that is being used for the collision detection is SISMA CD, right। अब आ जाएं 802.11। अब एक चीज मैं आपको और बता दूं, I mean whenever you are talking about wired standards, the IEEE standard that is being used, IEEE Ethernet standard that is being used is called as your 802.3। किसी भी डिवाइस के ऊपर, किसी भी केबल के ऊपर आपको यही लिखा हुआ नजर आएगा, केबल के ऊपर कभी भी आपको 802.11 लिखा हुआ नजर नहीं आएगा। This is a standard, make sure this is a general information you have to keep inside your mind, that IEEE 802.3 is an Ethernet based standard which is being used for wired networks, right। वायर्ड मतलब वायरलेस की बात नहीं हो रही, लेकिन जब हम वायरलेस डिवाइसेस की बात करेंगे, whenever we are talking about a wireless modem, we are talking about the wireless access point, any wireless device, that device is purely based upon your 802.11 IEEE standard। ये चीज आपने ध्यान में रखा। I mean if somebody asks you that this device is based upon your IEEE 802.11, तो आप समझ जाएं कि आपके पास ये ईथरनेट की बात नहीं हो रही। ईथरनेट का मतलब ये है कि वायर्ड की बात नहीं हो रही। जब 802.11 की बात हो रही है ना, दिस मीन्स दैट दिस इज अ स्टैंडर्ड दैट इज बीइंग यूज्ड फॉर द वायरलेस लैन, ठीक है। जब LAN is LAN, local area network, and when we are talking about a wireless means wireless standard, right? Is that clear? ठीक है। So we might have the SISMA, okay। अब देखें Ethernet जो 802.3 था, ठीक है, for that we are using what? SISMA CD, I mean carrier sense multiple access collision detection। When we are talking about 802.11 wireless LAN standard, we might be using for carrier sensing, we might be using carrier sense multiple access but collision avoidance। CA stands for collision avoidance। तो ये चीज आपके जहन में होनी चाहिए। For Ethernet, SISMA CD would be used। For wireless LANs, that is 802.11, we might be using SISMA CA, ठीक है जी। तो that is fine, that is clear। Now use radio signals at 2.4 GHz, IEEE 802.11 as it is a wireless standard। तो उसकी जो रेडियो सिग्नल की फ्रीक्वेंसी है वो आपके पास क्या है, 2.4 GHz, right। data rate that might be supported by this particular standard is 11 megabits per second, right। that is the latest but not the latest one। ये अभी भी पुराना है, अभी जो new devices हैं they might have the higher speeds, so this is bit better than the previous one। Now older devices might use radio signals at 9 megahertz per second, right। जो older devices थी जो radio signals को support करती थी, wireless की बात कर रहा हूँ मैं, they might have the speed that is 900 megahertz per second and 900 megahertz, right, and data rate of 2 megabits per second। I mean उसकी आप जो आपके पास data rate या bandwidth होती थी that is 2 megabits per second, right। So Bluetooth specifies a wireless LAN for shorter distance, shared medium radio instead of coaxial cable। Now you know that I mean to say that जो wireless LANs होते हैं, first of all you must be very clear regarding the wireless LAN। Inside your homes you might have an access point, right, and your laptop or your mobile is being connected with those particular access point through a wireless medium, ठीक है जी। वो रेडियो फ्रीक्वेंसी पे आपके पास कनेक्टेड होता है, उसकी फ्रीक्वेंसी कितनी होती है, इट डिपेंड्स अपॉन डिवाइस टू डिवाइस के जी आपके पास एक्सेस पॉइंट जो आपका है वो कौन सी फ्रीक्वेंसी पे काम करेगा। आई मीन इट इज वर्किंग एट अ फ्रीक्वेंसी ऑफ 2.4 GHz, राइट। इन द सेम वे you might have the devices which are being connected with that particular access point, so this is what you can call it as a wireless LAN। I mean if you're talking about the desktop computers, if you do have at your homes, you might have seen that कि आपके अगर आपने कभी कंप्यूटर परचेज किया हो, nowadays everybody is going to purchase a laptop, nobody have bothered about कि जी LAN कार्ड क्या होता है, but if you do have an experience of purchasing a desktop computer from a shop like the Yip Complex or something like that in last 1 or 2 years, जब आपने admission लिया होगा, तो you are going to build your CPU. You are going to I mean fix different sort of hardware inside your CPU. तो उसमें ये भी होता है कि आपका LAN कार्ड लगाना है जी. LAN कार्ड आपने कौन सा WLAN लगाना है, वायरलेस LAN कार्ड लगाना है या सिंपल LAN कार्ड लगाना है. I mean simple LAN card is being used for the connectivity for the wired networks. ठीक है, wired आपका जो RJ45 cable है, that is going to be inserted at the back end of your computer, and this is what you can call it as a normal LAN card. And then another one is called as your wireless LAN card. Wireless LAN card do have a certain sort of antenna. ठीक है जी, वो आपके पास बैक एंड पे लगता है. तो अब अगर आप if you are going to insert WLAN card inside your computer, तो that LAN card I think support both the connectivities. Wireless LAN भी वो connect करता है और guided media को भी connect करता है. So this is the difference between a wireless LAN and a simple LAN card, right? Wireless LAN card is going to give you an opportunity to connect with your modem, a wireless modem or something like that. I mean जो wireless devices होती हैं उनके साथ connectivity में आपको help करता है, right? So this is what regarding the wireless LAN, and make sure all the wireless devices always works upon an IEEE 802.11 standard. ठीक है, आई मीन यू डोंट हैव टू बॉदर अबाउट कि जी 802. जब भी आपको 802.11 आप किसी भी मोडेम को उठा के देख लें, किसी भी वायरलेस मोडेम को, एक्सेस पॉइंट को, उसकी स्पेसिफिकेशन में पीछे लिखा होगा कि दिस इज IEEE 802.11. कभी भी 802.3 नहीं लिखा होगा. लेकिन अगर आप आई मीन इफ यू आर गोइंग टू टेक एन STP और UTP केबल, ठीक है, अगर आप उसको उठाएंगे ना तो उसके ऊपर लिखा होगा IEEE 802.3 because that is Ethernet LAN standard, right? And when we are talking about a wireless LAN standard, it is 802.11, right? So Bluetooth, everybody knows that it is a very small distance range. आपके मोबाइल फोन के अंदर या आपकी ऐसी डिवाइसेस होती हैं जो गैजेट्स होते हैं which are going to connect two devices in a very short range, that is called as your Bluetooth technology, and it has a very short range between 10 to 15 or 20 meters. और वायरलेस LAN की भी आपके पास एक पर्टिकुलर रेंज होती है. यू कैन नॉट गोइंग आउट ऑफ दैट पर्टिकुलर रेंज if you want to have a connectivity through wireless LAN. ऐसा नहीं है कि your wireless access point is being placed inside your home and you are going to Hyderabad and you want to you think that कि आपके पास आपके वायरलेस लैन की या आपके वाईफाई की कनेक्टिविटी हैदराबाद आप जा रहे हैं तो वहां पे भी आए. नो, दैट मस्ट नॉट बी द केस. द मैक्सिमम लेंथ और द मैक्सिमम स्ट्रेंथ ऑफ नॉर्मल एक्सेस पॉइंट इज नॉट मोर देन 100 to 200 or 300 मीटर्स. आई मीन 100 या 200 मीटर से ज्यादा नहीं होती. उसके बाद उसके सिग्नल्स आपको नहीं मिल रहे होते. आई थिंक all this thing you have experienced at your homes also. I mean, let's suppose if your access point is being installed at your room, so you can just go out of your house, you will not experience the particular signals of that particular access point. ठीक है, तो every device, wireless device has a particular range कि किस particular range तक या किस particular frequency तक उसको आप access कर सकते हैं. So limited connectivity with wireless. In contrast with wired LAN, not all participants may be able to reach each other. Low signal strength, propagation blocked by walls. I mean, why wireless devices have the low strength? I mean, low signals. The reason is the wireless signals cannot penetrate through the walls, through the concrete walls. They cannot pass through certain sort of doors, certain sort of, I mean, these sort of things are going to create an intrusion or some sort of restriction or retraction between the signals. I mean, when the signals are propagating, they are going to provide or they are going to find certain sort of hindrances if you find certain sort of devices like tables, chairs, and the walls. So that is why you are going to experience less amount of signals when you are going out, because this device is being located inside your office, inside your room, and when your signal is being traveling from your room to outside, it might experience certain sort of hindrances like walls, like tables, chairs inside your homes or something like that. So for that reason, your signal is going to be decreased, the strength of the signal is going to be decreased, and when it reaches to the destination, it might not have that particular strength that a normal signal have, right? So that is why that is going to be propagation blocked by the walls. Can't depends upon CD. Not all participants may hear. Now see, when we are talking about CD matlab hai collision detection.
Yes, sir.
ओके आई मीन एक्चुअली व्हाट हैपेंड, सीडी इज कोलिजन डिटेक्शन। अब कोलिजन डिटेक्शन के अंदर आपके पास लेट्स सपोज अगर एक वायर लगी हुई है, दैट इज अ शेयर्ड मीडियम, दैट इज अ कोएक्सियल केबल, एंड 10 computers are being connected with them. Now all these computers knows each other and they are on the same medium. Inayat, is there any problem? You are accessing
सर
some.
बाय सर बाय मिस्टेक
Oh,
से प्रेस
oh,
हो गया।
okay. Can't depend upon CD. Not all participants may hear. So, fine. Mm, yeah. So, not all participant may hear over the can't depends upon. I mean, in a CD, sorry, in a collision detection, what is going to be happen कि आपके पास एक मीडिया है और उसमें 10 computers लगे हुए हैं. They are going to share the same medium. So every computer knows each other. जो भी उस medium के अंदर लगे हुए हैं, ठीक है? They are very much nearby. I mean, between a 3 meter distance, not more, not less than 3 meter distance, and they all are connected. So they know each other. But when we are talking about a wireless LAN, right, we do not have, I mean, devices which are inside a WLAN does not know each other. I mean, कोई आपके पास 10 मीटर की डिफरेंस पे होगा, कोई आपके पास 20 मीटर की डिफरेंस पे होगा. Let's suppose that you are sitting inside your room where the access point is. You are sitting very near to your access point. It might be 3 to 4 meter distance. At the same time, if one of your brother or sister is sitting outside of your room and he is going to access the same Wi-Fi or same WLAN, he might be or she might be at 30 meter or 40 meter distance. I mean, the difference, I mean, the devices might not know each other inside your wireless LAN standard. WLAN के अंदर आपकी devices को नहीं पता होता वो कितने डिस्टेंस पे हैं और कहाँ कहाँ लगी हुई हैं, ठीक है? लेकिन जब हम वायर्ड LAN की या ईथरनेट की बात करते हैं, in that particular scenario, each device is being installed at a particular distance on a shared LAN, right? That is why we are going to use CSMA CA collision, CD, CSMA collision detection in that particular network. So when we are talking about a wireless LAN, we might not be using collision detection mechanism. We are going to use the collision avoidance, right? How it is going to be used? Now see, limited connectivity with wireless. Now see, these are the computers which are connected with each other. This is the computer 2, this is computer 3, and this is computer 1. Now let's suppose computer 1 and computer 3, they both are at a different distance from computer 2. और computer 1 जो है वो computer 3 से डबल डिस्टेंस पे है और कंप्यूटर 2 जो है कंप्यूटर 3 से सिंगल डिस्टेंस पे. आई मीन इफ दिस इज 5 मीटर एंड दिस इज 5 मीटर, तो कंप्यूटर 2 फ्रॉम कंप्यूटर 3 एज 5 मीटर डिस्टेंस, बट कंप्यूटर 1 फ्रॉम कंप्यूटर 3 इज 10 मीटर डिस्टेंस. बट अगर हम यही सिनेरियो ले जाएं ईथरनेट लैन के ऊपर, ऐसा नहीं होगा. All computers are being connected with a single medium at an equal distance. So it might be a problem, right? So what we are going to do over here, we are not going to use a we are not going to use a collision detection mechanism over here. Over here, the collision avoidance is being used. Now, what is collision avoidance? The same like collision detection, but what is going to be happen? Your transmitter device, whatsoever the transmitter device there is, he is going to send a control signal to the receiver, right? I mean, receiver और sender दोनों computers ही होंगे in a wireless LAN, right? When they are going to send a signal to a receiver before sending the data, if the device is free, I mean to say that the receiver is free and try to receive the information, he will select a slot, or he will, I mean to say that assign a particular slot for that particular computer or for that particular sender, and then your data would be started sending and receiving with that particular computer, right? I'm again going to repeat it. Before sending the data, every sender in WLAN, मैं WLAN की बात कर रहा हूँ, every computer needs to send a control packet to the receiver. If the receiver has the tendency to receive the data, I mean if it is free and it can receive the data, it will assign a particular slot for a computer A. Now computer A can send and receive the data with computer B. This is how your sending and receiving is going to be executed during CSMA CA, right? So this is what the normal situation is. But if that control packet when reaches to the destination, and if destination is not free, I mean to say that destination is already sending and receiving the data from some other computer, it will discard the packet. It will discard that particular control packet. वो उसको discard कर देगा. Now, when that computer is going to discard that particular packet, जो control packet sender की तरफ से आया था, तो यहाँ पे back of time generate होगा. अब क्या करेगा? जो आपका sender है, it will put its it will take himself to an ideal condition that I have to go to a back of time assign हो जाएगा, and a particular back of time has been associated with that particular sender. Let's suppose 10 milliseconds, 20 milliseconds, whatsoever the machine has to select for that particular computer, and then that particular computer will go in the idle state. The same that is going to be happen in a collision detection mechanism. वहां पे क्या होता था, आपके पास एक particular back of time assign हो जाता था, and then it is going to be reawake when that particular time is going to be ended. In this particular situation कब होगा, आपका एक wireless एक कंट्रोल पैकेट सेंड किया जाएगा, सेंड इट टू रिसीवर. अगर तो वो रिसीवर फ्री है तो इट विल असाइन अ पर्टिकुलर स्लॉट एंड द डेटा is normally going to send and receive between these two devices. But if the destination is not free, it is already receiving and sending the data with some other device or some other computer, it will discard that particular. Make sure this is not a data packet. ये आपके पास एक control packet है. एक control bit है जो just check करने जा रही है कि आपका जो receiver है वो free है कि नहीं है. अगर वो उसको discard कर देता है, automatically your sender will understand that your destination is not free. So what it will do, it will apply a back of time to the sender, and your sender will go in the idle state for that particular amount of time. Now the same happens if again it is going to send the data and the data has been discarded by the it will again send the control packet to the receiver. If the computer is going to discard that packet again, your destination is going to discard that packet again, it will double your back of time, and so on, like it was happening in your collision detection mechanism. So this is how your CSMA CA is going to work inside a WLAN. Make sure your CSMA CA always works in WLANs and your CSMA CD always works on your Ethernet LANs. ठीक है जी, wireless use collision avoidance rather than collision detection. Transmitting computer sends very short message to receiver. Receiving computer responds with short message, reserving slot for transmitter. Response from receiver is broadcasted, so all potential transmit receive reservations. Right? That's what I have told you right now. Collision receiver may receive simultaneous request. Result is collision at receiver. Both requests are lost. Neither transmitter receive reservation. Both use back off and retry. Local talk. अब ये एक ना छोटी सी एक टेक्नोलॉजी थी that was been given by a Macintosh. Apple का तो I think everybody knows about Apple. जिसके iPhones हैं, हमारे पास Mac operating system है, right? So what they have given, LAN technology invented by Apple that use bus topology, right? They have given a technology interface included with all Macintosh computers, relatively low speed 230.4 kbps per second, low cost, free with a Macintosh, easy to install and connect, use CSMA CA. That is called as a local talk. अब ये आपके पास computers में थी. जो डेस्कटॉप जो लैपटॉप कंप्यूटर्स हैं मैक के मैक ऑपरेटिंग सिस्टम विथ मैकिंटॉश कंप्यूटर्स, उनके साथ उन्होंने ये टेक्नोलॉजी दी दैट इज कॉल्ड एज लोकल टॉक. अब एक्चुअली ये कैसे वर्क करती थी, इंटरफेस इंक्लूड विद ऑल मैकिंटॉश कंप्यूटर्स, रिलेटिवली लो स्पीड 230.4 kbps per second. Now this is the Ethernet WLAN that is going to connect. Let's suppose you have 5 मैक कंप्यूटर्स. ठीक है, आपके 5 फ्रेंड्स हैं, आपके पास 5 मैकिंटॉश कंप्यूटर्स हैं. अब आप या तो एक नेटवर्क बनाएं, ठीक है, you all need to transfer some data or you want to be a part of a network. Either you have to buy a central switch or central access point. All these computers are being connected with that central access point and then you can share the data. Secondly, they have Mac operating system or Mac computers have given you an access of local talk. उसमें उन्होंने क्या किया कि उन्होंने ये टेक्नोलॉजी दी लोकल टॉक की, जिसमें आप वायरलेसली उन सब के साथ कनेक्ट हो सकते हैं, उन 5 कंप्यूटर्स के साथ. What is the maximum speed that is being given by that particular local talk is 230.4 kbps per second. That is a very low speed, but at that time this was a very useful. तो उसमें आप लैंड टेक्नोलॉजी को यूज करते हुए आप अपने डेटा को सेंड और रिसीव कर सकते हैं. ठीक है, लो कॉस्ट, फ्री विथ ओके, मेक श्योर दिस इज फ्री विथ अ मैकिंटॉश. देयर इज नो कॉस्ट ऑन दैट, इजी टू इंस्टॉल एंड यू कैन कनेक्ट विथ योर कंप्यूटर्स लाइक यूजर्स CSMA CA. अल्टीमेटली दिस इज अ वायरलेस टेक्नोलॉजी, तो आपके पास CSMA CA इसके अंदर collision avoidance use हो रहा होगा, ठीक है. So that is regarding the local talk. Then we are going towards another technology that is called as what? That is called as token ring, right? Token ring क्या है? Token ring क्या है? अच्छा, the token ring is many LAN technologies that use ring topology use token passing for synchronized access to the ring. I think in the last lecture I have discussed with you the ring topology, and in response or in line with that particular topology I have discussed a token. ठीक है जी. अब token ring is a standard, make sure. ठीक है, जैसे Ethernet है ना, Ethernet use bus topology, token ring is based upon your ring topology. ठीक है जी. Ethernet के अंदर जैसे आपका access mechanism using SysMA CA और SysMA CD के जरिए होता है ना, in the same way if we have a ring topology or if we have a ring network, inside a ring network how your data is going to be accessed. अब देखिए आपके पास नेटवर्क तो है, उसके अंदर डेटा एक्सेस मैकेनिज्म को हमने अंडरस्टैंड करना है. अब जैसे ईथरनेट था हमारे पास, ईथरनेट के अंदर डेटा एक्सेस मैकेनिज्म कौन सा था? सिस्मा सीए और सिस्मा सीडी. फॉर वायर्ड लैन वी हैव वायर्ड ईथरनेट नेटवर्क्स वी हैव सिस्मा सीडी. फॉर वायरलेस लैंड्स व्हाट वी हैव? सिस्मा सीए, राइट? दिस इज द एक्सेस मैकेनिज्म ऑफ योर मीडियम. अब अगर हम रिंग टोपोलॉजी के अंदर आते हैं या रिंग नेटवर्क्स के अंदर आते हैं, तो रिंग नेटवर्क्स के अंदर हाउ योर डेटा इज गोइंग टू बी एक्सेस्ड, how your data is going to be accessed by that particular ring. ठीक है, तो उसके लिए जो टेक्निक यूज होती है that is called as your token ring, right? What? Token ring. So many LAN technologies that uses ring topology use token passing for synchronized access to the ring. Ring itself is treated as a single shared communication medium. Bits passes from transmitter past other computers and are copied by destinations. Any question? का माइक ओपन हुआ है. Okay, so look at this particular diagram. In the last class I have told you, last lecture I have told you regarding the ring. Hardware must be designed to pass token even if attached computer is powered down. I mean आपके पास ring topology के अंदर token ring कैसे work करता है? Every computer that is being connected through a ring topology only can send and receive the data that which computer do have that particular token. I mean the computer can only send and transmit receive the data which possess that particular token. Without token you cannot send and receive the data, right? Now if you can look upon this particular diagram, अगर आप देखें कि if you have sender receive bits of the frame, sender holding token transmit bits of a frame, computer not holding the token passes bits and destination passes and makes a copy. अब होता क्या है कि आपके पास let's suppose एक sender है. Now when sender would be sending the data? When it receives the token. जैसे ही उसने token receive किया, it will start transmitting the data. अब data जो है ना वो आपका इस तरह से travel करेगा in the clockwise direction. Travel किया, अब इसमें से ultimately there must be a single destination. All computers would not be a destination. आपके पास एक single destination होगी. Let's suppose this would be a destination. Destination के पास जाके data आपकी copy बनेगी. Destination will make a copy of that particular data and will send data to the next computer. आपका data आगे send होता जाएगा and again it will be received at the sender's end. आपके पास sender के पास आके वो again receive हो जाएगा. ठीक है, and as soon as the computer finishes by sending that particular data, it will pass on the token to the next computer and so on. तो इस तरीके से आपका टोकन पास होता जाएगा और जिसके पास होता जाएगा it will send and receive the data at that particular time, and the computer which do not have the token, it will not send the data at that particular time. Is that clear guys? ठीक है, so that was regarding the token ring. Using the token when a computer wants to transmit, वही चीज अभी मैंने आपको बताई है. After transmission computer transmit token on ring, next computer ready to transmit receives token and then transmits. Fine. So token and synchronization, fine, that's all I have told you. Because there is only one token, only one computer will transmit at a time. Token is short reserved frame that cannot appear in data. Hardware must generate token if lost. Okay, I mean yes, make sure one thing that I didn't told you. हार्डवेयर मस्ट, अब आपके पास जो टोकन है ना, इट इज सम सॉर्ट ऑफ कंट्रोल बिट, आप समझ लें इस तरह से। एक कंट्रोल बिट है जो ट्रांसमिट हो रही है फ्रॉम ईच कंप्यूटर, फ्रॉम वन कंप्यूटर टू अनदर कंप्यूटर, फॉर एनी रीजन दैट इफ दैट कंप्यूटर, इफ दैट टोकन इज गोइंग टू बी लॉस्ट, अगर आपके पास वो कंट्रोल बिट लॉस हो जाती है, तो देन व्हाट इज गोइंग टू बी हैपन, योर हार्डवेयर मस्ट रीजनरेट दैट पर्टिकुलर टोकन, राइट? So this is how your token ring technology is going to work, right? IBM is a well-renowned company. They have given their first technology, token ring technology, very widely used. Originally 4 megabits per second, now 16 megabits per second is the speed of the token ring networks. Use special connector cable between computer and the ring interface. ठीक है जी। तो IBM ने जो basic concept token ring का दिया था, that is from the IBM, and they have the ring speed of 4 megabits per second to 16 megabits per second. अब आ जाएं FDDI पे, ठीक है जी। Token ring was used for ring networks. Ethernet was used for bus networks. अब जो FDDI है, that will be used for the ring networks, right? FDDI would be used for the sorry. FDDI, not ATM, would be used for the star networks. ठीक है जी। अब FDDI जो है ना, that would be an called as your fiber distributed data interconnect, that is called as FDDI, is another ring technology. ये आपके पास एक और ring technology है, I mean that you may call it as an extended version of an FDDI, right? So it uses fiber optics between stations, transmits data at 100 megabits per second, use pairs of fibers to form two concentric rings. अगर हम पुराने रिंग, सिंपल रिंग की बात करें, तो सिंपल रिंग माइट हैव एन स्पीड ऑफ, व्हाट इज द बैंडविड्थ, 4 megabits to 16 megabits per second, ठीक है? ये आपके पास स्पीड है IBM टोकन रिंग की, राइट? IBM टोकन रिंग जो था उसकी स्पीड आपके पास 4 Mbps थी। लेकिन इफ यू आर टॉकिंग अबाउट FDDI, that is called as your fiber distributed data interconnection. It might be the extended version of ring topology or ring networks, and it might have a speed of 100 megabits per second. You can imagine कहाँ पे 4 megabits per second and where the 100 megabits per second. It might uses pair of fibers to form two concentric rings. अब देखें, come to the diagram. Right. Okay. First of all, I would like to read for you FDDI and reliability. So FDDI use counter rotating signs rings in which data flows in opposite direction. अब इसमें देखें दो rings होती हैं हमारे पास, ठीक है? In single ring, data moves in one direction. In the second ring, the data moves in opposite direction, counter clockwise direction. ठीक है जी? दोनों rings में आपका data opposite direction से move कर रहा होता है. In case of fiber or station failure, remaining stations loop back and reroute the data through spare ring. All stations automatically configure loopback by monitoring data ring. अब देखें होता क्या है? If you can look upon this particular diagram, the diagram number A, ये वाली जो diagram है ना, everybody can see this diagram clearly. If I'm going to make it like this, okay? अब देखें इसमें क्या है, हमारे पास दो रिंग्स हैं। जो आउटर रिंग है उसमें आपका डेटा यूज हो रहा है, आई मीन डेटा मूव हो रहा है, और जो इनर रिंग है दैट इज idle, दैट इज फ्री। आई मीन इफ देयर इज सम प्रॉब्लम विद द आउटर रिंग, तो आपके पास अगर वो डिस्कनेक्ट हो जाती है तो आपका सारे का सारा जो लोड है दैट विल कम टूवर्ड्स द इनर रिंग, ठीक है? इनर रिंग पे आ जाता है। अब देखें, आउटर रिंग यूज फॉर डेटा, इनर रिंग अनयूज एक्सेप्ट ड्यूरिंग फेल्यूर। जब आपके पास आउटर रिंग फेलियर हो जाएगी ना, तो आपका जो सारे का सारा डेटा है वो इनर रिंग पे आ जाएगा, लेकिन मैकेनिज्म सारा सेम है, लाइक यूर token ring topology. Your token would be passed through each computer. The computer which possesses that particular token can send and receive the data. Now let's suppose if this computer fails, आपका ये computer fail हो जाता है, नॉर्मल रिंग के अंदर क्या होगा, योर होल नेटवर्क गोज डाउन, एज आई हैव टोल्ड यू इन द लास्ट क्लास, आपके पास पूरे का पूरा नेटवर्क डाउन हो जाएगा। रीजन इज देयर इज नो एनी अदर कनेक्टिविटी बिटवीन दीज पर्टिकुलर कंप्यूटर्स, योर नेटवर्क गोज डाउन and you have to you cannot do anything, right? But when we are talking about your FDDI networks or FDDI rings, if this is going to be disconnected for any reason, अब होगा क्या, your data is traveling through the outer loop, वो क्या करेगा, आपके पास inner loop के ऊपर डेटा ले जाएगा, ठीक है? Now your data is being traveling in an inner loop is something like this, as you can see in this particular diagram. आपके पास एक loop back रिंग क्रिएट हो जाएगी एंड दिस वुड बी डिस्कनेक्टेड। अब आपका डेटा ना यहाँ पे जाएगा ना यहाँ पे जाएगा, तो अब ये आपके पास इनर लूप के अंदर इस तरह से मूव करना शुरू कर देगा। सो दिस इज हाउ स्टेशन एडजेसेंट टू फेल्योर लूप्स बैक। सो आपके पास ये लूप बैक करेगा और इस तरह से आपका एक नेटवर्क बन जाएगा। सो दिस इज हाउ योर FDDI might works, right? So that is regarding the FDDI, how it is going to be reliable. I have told you that if there is some loss of the data, loss of the station, if some station is not working properly or malfunctioning, your network will not go down. It is reliable. It will change the path and it will take the second path to send and receive the data over the network. ठीक है जी। अब ये हो गया हमारे पास for the ring topology. For the ring topology, we are using two access mechanism. One is called as your token ring. Another one is called as your FDDI. ठीक है जी। बस के लिए हम क्या यूज कर रहे थे? SISMA CD and SISMA CA. Now the last topology that was remain, that was called as your ATM, sorry, star network. अगर हमारे पास star topology है तो we might be using the mechanism or the standard that is called as your ATM. ATM stands for asynchronous transfer mode. Technology consists of electronic packet switches to which computers can connect. ATM switch from hub into which computers connect in a star topology. Computers get point-to-point connections. Data from transmitter is routed directly through hub switches to a destination. If none ready to transmit, token circulates around ring. If all ready to transmit, enforce round robin access. Right? इसमें आपके पास क्या होता है? You have the central switch and all the computers are connected with a central switch like a point-to-point connection. Any computer who wants to send the data, it will be received at the receiver's end and then it will not broadcast. Make sure आपके पास hub के अंदर broadcast होता है लेकिन यहाँ पे broadcast नहीं होता. It will send that particular data to a particular destination. Let's suppose this is computer B, this is computer A. Computer A ने data send करना है, यहाँ पे receive होगा इस point के ऊपर. ATM switch check करेगा कि इसकी destination क्या है. It will send data to a particular destination, that is computer B. इस port पे receive होगा and then it would be received by the receivers and that is called as computer B. But if there is a hub over here, तो hub ऐसा नहीं करती. hub क्या करती है? आपके computer A ने data भेजना है computer B को. What is going to be happen? Computer A would send the data. It would be received over here. What will the hub do? Hub will broadcast that data to all the connected devices with that particular hub. ठीक है, तो कितनी डिवाइसेस कनेक्टेड हैं? 1 2 3 4 5. देयर आर 5 डिवाइसेस व्हिच आर कनेक्टेड. तो सबको ब्रॉडकास्ट की जाएगी. All others would discard the data. Only computer B would accept that particular data. तो डेटा वही कंप्यूटर रिसीव करेगा जिसके लिए वो डिजाइन होगा. I mean for which it is for which the data has to be received. ठीक है. All other computers would discard that particular data. So this is how your ATM works and it always works in a star network or star topology. ठीक है जी. So ATM details transmit data at over 100 megabits per second. Use fiber optics to connect computer to the switches. Each connection includes 2 fibers. Actually, these are few older concepts that के switch के साथ fiber connect होता था पहले, लेकिन अब हमारे पास जो हमारी STP और UTP cables हैं, they might have the capability to transmit data up to 100 megabits or per second. ठीक है. तो nowadays we do not connect fiber with a computer to a switch or from switch to a computer. We are connecting our computer with a switch with a UTP or STP cable and you people have seen that particular network inside your labs. ठीक है जी. तो this is some diagram for with the older computers. You may see here these yellow and orange are the optical fiber cables which are being connected with your computer. One end is being connected with the computer and another end will be connected with the switch of that particular lab of that particular lab. So if this diagram, if you can see here, आपके पास एक computer है and you have a ATM switch and one is fiber is for sending the data, another one is for receiving the data. This is how, but this is an older technology. Nowadays we are not connecting switch fiber with a switch and computer. We are using an STP and UTP cable. The reason is now we do have the higher bandwidth STP and UTP cables available in the market, right? So ATM switch का ये to say that एक पुराना version है. and this is the front end, this is the back end, and this is the front end. I think you people have never seen ATM switch before. ठीक है, आपने normal switch तो देखा होगा, लेकिन ATM switch नहीं देखा होगा. ठीक है जी. So this is a summary of this particular chapter.